today we're going to look at what it is that a forensic chemist actually does. What are the requirements for their job in regard to accuracy and reliability. And we're also going to go through one particular case study to see how forensics have changed, or forensic chemistry indeed has changed a little bit, and how that change, the change in technology, change in understanding, could have altered the outcome of the particular case that we're going to look at, which will be an Australian case. I'm sure you'll have heard of it when we get there. So what's the point? Basically, by the end, you know, explain what a forensic chemist is, what forensic chemistry is, and the necessity of the precautions taken. Now, here we have two scenes. One is a real scene, and the one is from a TV show. Very clearly, this is the one from a TV show. You can see we have quite an attractive corpse lying on the ground for no reason. And we can see here that we have a balding middle-aged man working and contaminating the scene with his falling out hair, and there's all sorts of problems. And this is, again, so obviously TV, reality. And here we have a TV lab, and here we have a real lab. And once again, you can see the difference. All right, so what is forensic chemistry? Basically, it's just the application of chemistry to either law enforcement or any sort of investigation, really. Many different analytical methods are used, and because of this, you'll never see in a lab one forensic chemist. You'll see lots of forensic chemists working together. Accuracy and integrity. This is really what we're going to talk about mostly today. It's vital. It's vital because their work is used in criminal court. So we've got suspects who face conviction to jail. All right, this is a real issue. You don't want the suspects to get off with the crime if they did do it, and you don't want them to, probably just as important, if not more important, you don't want people going to jail for something they didn't do. And also in civil court, where up to large fines and compensation can be, required to be paid by either people or corporations. So forensic chemistry is used there as well. But the thoroughness really is vital. It's really important that when the evidence looks like it's got to a certain point, you don't stop. You keep going, because you don't want for it to look like it's going to convict someone, but some of the evidence that gets gathered later on might turn that around. It needs to be accurate and reproducible, which means it's going to be reliable. How do we meet these conditions? Also, by the way, so we're not just using criminal cases. Any investigation carried out in a systematic way. So you may need to investigate drug usage, both for athletic, recreational, problems with working, chemical incidents, so industrial, like we had over at Blaney recently, research, or criminal. And homicide and assault and various other series of crimes. So, what needs to happen? Basically, all your apparatus needs to be thoroughly clean. And when we're talking about biochemical stuff, which is what we're going to be talking about a lot this term, this topic, it needs to be sterile. Aseptic conditions, that means clean. Septic is dirty, aseptic is without dirt. You must wear suitable attire. So, normally we get you to wear safety goggles and sometimes gloves in a lab. You're going to wear that in a forensics lab, but for a different reason. Not just for safety, but also to reduce contamination and hair nets, etc. The scientific method, you need to have control groups as standards. Okay, so you need relevant reference specimens, so something to compare it against, or blanks used as controls. Okay, we'll talk more about that in class. So, very, very important that the work is completed with standard and recognized protocols. In other words, you're not trying out fancy stuff when you trial out new ideas, but not during an investigation. You might come up with new ideas and you'll trial them, and once they're accepted, they might become the new standard. But you don't trial them out during an investigation. The lab needs to be accredited. Okay, this is done through quality assurance. QA means quality assurance. So a bunch of quality assurance testing is done with each lab to make sure that it maintains its accreditation. If a lab is not accredited, it will not, like the evidence from there will not be admissible in court. So with very small samples, ones we call trace samples, very large errors can occur, absolute errors. Therefore, the error margins and levels of certainty need to be stated in the report, and you must not understate them. It's really, and we're going to say this a lot during this video, it's really important for forensic chemists to be conservative. And I don't mean you vote right wing and wear a tie everywhere. I mean you need to underestimate as opposed to overestimate the conclusions based on your evidence. You need to have careful and correct labeling. It does happen that there are mishandling errors. That's really an issue. The chain of custody is really important, okay? For example, you'll never be able to collect evidence without signing it out paperwork at each stage and transfer. This is important so we know that the evidence wasn't tampered with. And they also need to be stored securely and safely, so for the right conditions. You don't want to store a blood sample in a hot, dry room. You want to keep it in a fridge, but you want to keep it in a fridge which is locked. So yeah. Results need to be documented and checked. This means independently. Different analytical chemists will also do the same experiments just to make sure that your work is where it should be. Reports and your logbook. So this would be your lab book. Reports and logs, they can be used as evidence. So all steps of we're going to go over this again in a little bit. All steps of the process are to be transparent and available at request, which means they must be accurate and clear. Now, contamination and errors undermine the accuracy of a forensic investigation. So, how does this occur? Basically, the addition of other materials during collection. So, when we handle it, transport it, they need to be sealed as quickly as possible. We don't want to add anything in there because that's one extra thing we need to cancel out. And if you add something to it, you can't tell if when you measure it later on, it's tough to work out if that was already in the sample or if something you just added to it. So an unclean environment, such as labs with flaking paint, corroding instruments means stuff will come off into it. Lack of ventilation, which means dust and stuff will be hanging in the air. These can invalidate the results. It's really important that our lab is looked after, our lab is clean, and it's also really important that if we're having any issues, we report it, which we'll see later on. Carelessness. So, not wearing suitable protective clothing. So, lab coats, gloves, face masks, hair covers. You don't want to get dust, dandruff. You don't want to breathe into a sample. You don't want to sweat into a sample. These are all things which can, add certain elements to it, or DNA. Samples must be analysed using standard and internationally accepted techniques. So, once again, this gets us down to standard protocols and accreditation for quality assurance. Chain of custody. If the chain of custody is broken, we won't be able to use that evidence. So if the chain of custody is the person collects it, then it gets signed off by the police officer who takes it in, then it gets signed off by the person storing it, and so forth. That needs to be maintained at all times. Otherwise, the evidence that you've collected loses its validity. So why is accuracy so important? Well, there are two reasons. One is the CSI effect. So a lot of forensic evidence, it used to be that eyewitness was the one that people really look for, but when these shows like CSI, Bones, etc. started to become really popular, it started to overpower certain types of evidence. For example, DNA. Essentially, most often DNA just says someone was there at some point recently. It doesn't say they did it, but the second DNA evidence comes out, a lot of jurors go, that's it. That's your killer, or that's your criminal. So the CSI effect is one. The other one is the unreliability of eyewitness testimony. For a long time, for I don't know, as long as we've had courts, 800 years, eyewitness has been the gold standard. But it shouldn't have been. It never should have been. It's extremely unreliable. That's particularly true when someone is when the suspect is from a different racial background to the eyewitness, and it doesn't matter which way it goes. People suffer from racial blindness, and that's just one aspect of it. There's also people during a crime, they're going to be stressed, or they're not paying attention in the first place. But we replay things in our mind, and that builds up the level of importance. We build up our memories. They're not something that we actually, they're not recorded. They're reconstructed every single time. Um, so there are some ethical issues to look at. Now remember, these are going to be used in court to convict or acquit a suspect. So we need to have some ethical standards. For example, analysis needs to be carried out thoroughly and accurately. Okay, professional, qualified, no shortcuts, and analysis must be repeated for reliability. Um, Remember, repetition does not increase reliability; it shows reliability. Um, we need to analyze all of our samples from all suspects, and we don't stop when one sample shows that or appears to incriminate a particular suspect. We need to do samples from all suspects, and to be honest, you need to analyze samples from a lot of the police, people working for the police, and this will help minimize your contamination. So people working in the lab, they'll be tested as well, just to make sure that, if something pops up, we know it's theirs and it's come from a contamination within the lab. You need to be objective in their reports. Okay, so you can't be influenced. You must be impartial during all stages of the investigation. One way that we show impartiality is we have often, instead of labeling it with a suspect, labeling our evidence with a suspect name, we'll label it with a suspect A and B, and the chemist will never know who suspect A is, who suspect B is. So all evidence must be disclosed, even your contradictory evidence. We cannot exaggerate, and so we can't go with one side or the other. If you lose something, or you damage a sample, or you contaminate a sample, or you know that one process you used is inaccurate to a certain extent, you must state this. You must report this, and you need to report the limitations of your certain techniques. It needs to be clear and concise, your report. It needs to use layman terms, okay? So you don't use jargon, pretty much, because that will confuse or mislead people. And you basically you've got to keep everything confidential. You can't be, I don't know why it says that was where I stopped it. You can't be releasing anything. If you do, it can result in a mistrial. That's what I say. This could result in a mistrial. All right. So we're going to finish with a case study, a very sad case study. So we go back to 1980 in August. Azaria Chamberlain, a baby girl, went on a camping trip. She was 9 weeks old with her family to Uluru. Lindy and Michael Chamberlain claimed that one night she was taken from their tent by a dingo. Her body was never found. So what we have now is we have a missing child, and the parents claim that she was taken by a dingo. So the forensic evidence actually looked as though it was Lindy Chamberlain who murdered her child. So she was tried and convicted of murder, and this was down to fetal blood, so baby blood, being found in the family car. Now, a few years later, and Lindy's in jail at this point, Lindy Chamberlain's in jail, the baby's jacket and jumpsuit were found. The damage to him supports the claim that a dingo took the child. The standards of analytical chemistry had changed, and we were able to find that because the evidence was stored properly, that the fetal blood found in their car was indeed adult blood contaminated with rust. And this went along with the original story that the parents told. She was eventually declared innocent, or actually she was declared not guilty. They're a different thing. She was declared not guilty and released. If we had DNA technology back then and stored the blood properly, which we had, we could have found very early that the DNA inside the blood did not match that of either the mother or the father. Now, if it doesn't match either the mother or the father um, in any way, shape, or form, that means it's from an unrelated person. So, and therefore not the child. And that was the key bit of evidence. Aside from that, it was the way she appeared to, it was personality that really convicted Lindy Chamberlain, and that dodgy bit of evidence. So as we can see, technology changes. This means the results of court cases can change. And this is actually an argument against the death penalty, is that we're very confident in our evidence of a time, but later on we often find out that there is a better way to do things. Anyway, that's it for today. We'll see you in class, and yeah, enjoy.